This video is on inverses and compositions. So here we go. Maybe. There you go. Example 1, it says if f of x equals 2x plus 1, show that f of negative 1 of x equals x minus 1 divided by 2. So this one doesn't technically involve compositions. It's more of just showing that the two are inverses. So how I would go about solving this is first, I'm going to take this function right here, and I am going to find the inverse of it. So remember, f of x is a fancy way to write y. It's in function notation, so I'm just going to switch it, f of x to y. To find our inverses, we switch our x and our y, so we get x equals 2y plus 1. Okay, and now I just solve for y. So to solve for y, I subtract 1 from both sides. I get x minus 1 equals 2y. And to solve from y from here, I divide both sides by 2. I get x minus 1 divided by 2 equals y. And if I look, this matches this over here, which shows the two functions are inverses. So yes, they are inverses. I showed my work. There's another way we can go about it. We could use composition of functions. So what I mean by that is, I'm going to switch colors. If I find f of g of x, and then I find g of f of x, notice my input, this is my input, is x. My output would have to also be x in order for them to be inverses. So if my output is x, then they are inverses. So what this would look like is I would take f, g of x is equal to, oh, we don't have g of x, so let me correct my mistakes right here. It should not be g of x. It should be f of negative 1 of x. So here we go. F of negative 1. There we go. That makes a lot much more sense. So f of negative 1 of x equals x minus 1 divided by 2. So what this means is anywhere I see an x, I'm going to plug in x minus 1 divided by 2 in f of x. So that looks like 2 times x minus 1 over 2. And then I have plus 1. Well, 2 times that fraction, the 2's end up canceling out. I'm left with x minus 1 plus 1. Combine my like terms. Negative 1 plus 1 is just 0, so I'm left with x. That matches the output. Good check mark. Okay, if I look at the second part, I'm just going to do the opposite. So I have f of negative 1, f of x equals 2x plus 1. So anywhere I see an x in the inverse function up here, I am going to plug in 2x plus 1. So what that looks like is I have 2x plus 1 minus 1 divided by 2. Well, I combine these like terms, and 1 minus 1 is 0, so I'm left with 2x divided by 2. Well, the 2's cancel out. I'm left with x. My output is x, which is what I wanted it to be. My input was x on both compositions, so when my input matches my output, they are inverses, so that shows it. So again, on something like this, I would most likely solve it in the pink way, but you can also use compositions. So the next few examples, we're going to use compositions just so you can see what this looks like more. Example 2, we want to determine by compositions whether each pair of functions are inverses. So I have f of x and g of x, so I'm not going to mess up this time. I'm going to go ahead and switch my colors just for fun. So we want to find f of g of x, and we want to find g of f of x. And there's a couple of things I want to do here just to kind of show you. So first, I'm going to use x as my input. Again, my idea goal to show that they are inverses is that my output is also x. So if you want to write down in your notes, input x, output x, then functions are inverses. This only works for compositions, so that's what I'm talking about. So that's why I just didn't say it. So again, it only works for compositions. So f g of x equals the 3/2 x minus 9. Okay, so I'm going to plug that in. So I have 2/3. Instead of x, I'm plugging in the 3/2 x minus 9 plus 6. I distribute 3/2 times, not 3/2, that's 2/3 times 3/2 is just an x. 2/3, I can't say my right words today. 2/3 times a -9. Well, I'm going to multiply 2 times -9. That is a -18. I take -18, I divide it by 3. That's a -6 plus 6. Combine these two like terms. -6 plus 6 is just x. My input was x. My output is x. So far, we're on the right track for them being inverses. Now, over here, I have g. Instead of f of x, I'm going to replace it with what f of x equals, which is 2/3 x plus 6. So anywhere I see an x, I'm plugging that in. So I have 3/2 times 2/3 x plus 6 minus 9. I distribute 3/2 times 2/3 x. That just leaves me with x. 3/2 times 6. Well, 3 times 6 is 18. Divided by 2 is a positive 9. Minus 9. Combine your like terms. 9 minus 9 is 0, so I'm left with x. Again, my input was x. My output was x. So yes, they are inverses. Now, you don't have to just use x. So I'm going to show you what this would look like if we chose to use a number. So I'm going to choose the number 6. I say 6, I write x. 6, there we go. And I'm going to do this one over here using 6 as well. So what this would look like, I'm going to find g of 6 first. So g of 6 equals 3 times 2 times 6 minus 9. Well, 3 times 6 is 18, divided by 2 is 9, minus 9, which equals 0. I find f of 0, which gives me 2/3 times 0 plus 6. Well, 2/3 times 0 is 0, plus 6 is 6. So my input was 6, my output equals 6. So I double check over here. So I'm going to start with finding f of 6 first, which gives me a 2/3 times 6 plus 6. Well, 2 times 6 is 12, divided by 3 is 4. So I have 4 plus 6, which gives me a 10. And now I have to find g of 10. So I get 3/2 times 10 plus 9 minus 9. So here we go. Making sure I didn't make any mistakes. I always feel like I mess up. So I get, let's see, 3 times 10 is 30, divided by 2 is 15, minus 9, minus 9. 15 minus 9 gives me 6. My input was 6, my output was 6, so this is just another way to show that they are inverses. Let's do one more showing asking if they're inverses using compositions. I'm going to go ahead and switch to this one. That last example, they're not inverses, but this is one that I would like to show. So again, we're using compositions. I'm just going to stick with x this time. If you want to use a different number, it doesn't matter. You can pick any number in the world, but I just want to use x now. So I'm going to start with g of x equals 1/3 x minus 3. I'm going to plug that in for the x in f of x. So I have 3 times 1/3 x minus 3 plus 6. Well, I distribute 3 times 1/3 x is just a 1x. 3 times a -3 is a -9 plus 6. 9 minus, or a -9 plus 6 is x minus 3. My input was x. My output is -3. This is not looking good for this one. So here, my input is x. G of f of x is 3x plus 6. So I plug that in for my x. So I have 1/3 times 3x plus 6 minus 3. I distribute the 1/3. 1/3 times 3x is just a 1x. 1/3 times 6 is a positive 2 minus 3. X plus 2 minus 3, combine these terms. 2 minus 3 is a -1. My input was x, my output is x minus 1, which shows they are not inverses. So not inverses. So there we have it. This is how you use compositions to determine if two functions are inverses. If we really wanted to, we could have just switched this to its inverse form, f of x to its inverse form, and we would see that it's not the same, but the directions said to do it using compositions, so that's what we did.